Our lesson today is lesson 12.2, adding or subtracting polynomials. What do we mean by adding or subtracting polynomials? We either add or subtract our like terms. How do we rewrite it? We write it from greatest to least exponent, which I mean the standard form. Okay, this is our first example. They're going to give you two parentheses with a sign in the middle. What do I do to it? I distribute my sign into my parentheses and then I rewrite it all as one whole expression. I bring down my first parenthesis, minus 8x to the third plus 4x to the second plus x plus 1. I move on. I have a plus sign, so it's plus 3x to the third, plus and a minus give me a minus 2x to the second, a plus and a plus give me a plus 7. And now I start looking for my like terms. I underline and I make zigzags on like terms. This to the power of 3 is similar to this. This is to the power of 2 and this is to the power of 2. And this plus 1 and a plus 7. How do I rewrite them? I grab them together and I put them beside each other. Minus x, 8x to the third, plus 3x to the third, plus 4x to the second, minus 2x to the second, and I have a plus x here, and a plus 1, and a plus 7. And I start adding and subtracting my like terms. Negative 8 plus 3 is a negative 5x to the third, plus 4 and a negative 2 gives me a plus 2x to the second. I do not touch my variables. I leave them as they are because I am simply only adding and subtracting my coefficients that are beside the variable. Plus x, it has no like term. I bring it down. Plus 1 and a plus 7 give me a plus 8. Is it in standard form? 3, 2, 1, 0. Yes, that's my answer for this. Alright, our second example is this again. The first thing I do, I take off my parentheses, but here I have a negative sign. What do? I distribute it into my parentheses. I rewrite the first parenthesis as it is, 6x to the second plus 4x minus 7. And then a negative times a 2 gives me a negative 2x to the second. A negative and a negative give me a positive x. A negative and a positive give me a negative 8. So it's actually I am distributing the sign to the second parenthesis, not to the first. And now I look for my like terms. This and this are like terms. This is a plus 4 and a plus x. And I rewrite them, grabbing them together. 6x to the second minus 2x to the second plus 4x plus x. And I have a negative 7 and a negative 8. And I start adding and subtracting my like terms. 6 minus 2 is a 4x to the second, plus 4 plus 1 is a plus 5x, negative 7, negative 8 is a negative 15. Are they in standard form? To the power of 2, to the power of 1, 0, yes they are. I look at my second example, and again, I draw my arrows to change my signs in the second parenthesis. I rewrite my first parenthesis as it is. I do not change anything in it. And then I take the negative sign and I give it to my second parenthesis. Negative times 4 is a negative 4x to the second. Negative and a negative is a positive 5x. A negative and a positive is a negative 11. And now, where are my like terms? x2 and an x2, 4x and a 5x, a negative 9 and a negative 11. I rewrite it again. X to the second minus 4x to the second, plus 4x plus 5x, again, negative 9, negative 11. And I start adding and subtracting. 1 minus 4 is a negative 3x to the second. A 4 plus 5 is a plus 9x. Negative 9 and a negative 11 is a negative 20. Is it in standard form? To the power of 2, to the power of 1, power of 0? Yes, and that's my answer. All right. In the book, they give you many different methods. They give you the vertical method, the horizontal method. I don't want you using any of these. Just do the distributive property method. It's the easiest and it helps you in grade 8 for everything we're going to be doing. Okay? So the first thing, we take off our parentheses. There's a plus sign. I distribute the plus into my second parenthesis, into everything in it, and I start rewriting my first parenthesis, 2x to the fourth plus 6x to the third minus 5x to the second plus x minus 7. And then a plus x to the third, plus and a minus 3x to the second, plus and a plus 2x, plus and a plus 1. And I start looking for my like terms. 2x4, it doesn't have any like term, so I bring it down as it is, 2x to the fourth, x to the third and x to the third, here and here, so plus 6x to the third plus x to the third, and then I have a negative 5x to the second and a negative 3x to the second. These are like terms, negative 5x to the second, negative 3x to the second, and then I have an x and a 2x, which are similar, plus x plus 2x, and then I have a negative 7 and a plus 1, a negative 7 and a plus 1. And now I start adding and subtracting. This does not have a like term. I bring it down as it is. Plus 6 plus 1 gives me a plus 7x to the third, minus 5 minus 3 gives me a negative 8x to the second, plus x plus 2 is a plus 3x, negative 7 plus 1 is a negative 6. Is it in standard form? 4, 3, 2, 1, 0, yes, and that's my final answer. Now we look at this example. There's a negative here, and I need to distribute the negative into my parenthesis, so I'm going to be changing signs. I rewrite the first parenthesis as it is, and then I move on to my second parenthesis. A negative times a 3 is a negative 3t to the third. A negative and a plus gives me a negative 2t to the second. A negative and a negative give me a plus t. A negative and a positive give me a negative 4. And now I look for my like terms. 1, 3t to 3. This does not have a like term, it's on its own. Plus 7 plus t, and this is on its own. So I use these signs for me to differentiate where are my like terms. I bring them down, I combine them. Minus 3t to the third, negative 2t to the second, it doesn't have a like term, plus 7t plus t, and then a negative 4. And I start adding and subtracting. 3 minus 3 is a 0, goes away. I bring down the negative 2t to the second. Plus 7 plus 1 is a plus 8t, and I bring down my negative 4. Is it in standard form? To the second power, to the first power, to the 0 power? Yes, it is in standard form. This lesson is all about actually distributing the negative or the positive sign into the second parenthesis. That's it. So I rewrite my first parenthesis, 2x to the second plus 7y to the second. I give them negative sign to the x to the second. A negative and a negative give me a plus y to the second. A negative and a negative give me a plus 18. And I start looking for my like terms. This and this, this and this. And I rewrite them again. 2x to the second minus x to the second plus 7y to the second plus y to the second plus 18. I start adding and subtracting. 2 minus 1 is 1, x to the second. Plus 7 plus 1 is a plus 8, y to the second plus 18. Here it doesn't matter which comes first because both of them have the same degree, but the x comes before the y, that's why I leave it. But I can rewrite it again as an 8y to the second plus 1x to the second plus 18. Both are the same. Okay, let's look at the perimeter. Find the perimeter of the following figure. You have a triangle with x minus 5, x minus 3, and 2x minus 10. What's the perimeter? It's the sum. So I rewrite P is equal to 2x minus 10 in parentheses plus x minus 5 plus x minus 3. And I open my parentheses up. I distribute. So it's 2x minus 10 plus x minus 5 plus x minus 3. And I start looking at my like terms. 2x, x, and an x, which is a 4x. Negative 10, negative 5 is a negative 15, and negative 3 is a negative 18. So this is my perimeter of the figure. Our last example is this. There is a triangle, and within it, a rectangle, okay? They've given me the area of the total figure, and they give me the area of the unshaded part. The question says, write an expression to represent the area of the shaded region. So I am looking for this area only. Given the total area, which is this is my total area, and this is the area of the unshaded. What do I do? If I want to find this area, what do? I simply take the total and take away the area of the unshaded. So I write down the total, x to the second minus 4x plus 10 in parentheses. I subtract the x to the second minus 5x. Why can't I write it without a parenthesis? Because then I'm not going to be able to distribute my negative sign. Always remember, adding and subtracting is about distributing the negative or the positive sign into your second parenthesis. So here I have to distribute. I rewrite the first expression, x to the second minus 4x plus 10, a negative x to the second, a negative and a negative give me a positive 5x. I start looking for my like terms. This is a like and this is a like. So I rewrite them, bringing them together beside each other, minus 4x plus 5x plus 10. And now x minus x gives me a 0, goes away. Minus 4 plus 5 gives me a 1x. And then I bring down the plus 10. Always remember in this lesson, guys, you have to distribute either a positive or a negative to the second parenthesis. The first, always you bring it down, and never use the methods they have given you in the textbook because it's going to mix you up. The easiest method is distributing, opening it all up, bringing your like terms together, grouping them together, and then adding or subtracting and bringing down your final answer, always in standard form, from greatest to least exponent. This is very easy. I hope you do them well. Any questions, you can ask me on eSchool.